Hi everyone, my name is Brittany and I am going to be showing you all today what our equilibrium constant K is and what the reaction quotient, which is represented by Q, and what that all entails. So first off, I have a general reaction here in terms of A, B, C, and D, and you can see that when we write our K equation, that's always going to be our products over our reactants. So in this case, K, just in general, it's going to represent what are those concentrations of the products in comparison to the reactants that will give us an equilibrium value. So K, specifically in this case, Kc, which is just represented by concentration, is how many products and how many reactants do we have in comparison to each other when we're at equilibrium for a particular reaction, whereas this is just a generic reaction. So later on we'll get into Q, but first I wanted us to go through these 4 different scenarios. So first off, let's just stick to K, and then we'll go into what Q and the reaction quotient means. So starting off, what does it mean when K is greater than 1? So if we have a value that's greater than 1, we know that we have, in terms of a fraction, we're going to have our products on the top and our reactants on the bottom, like we see in this reaction up here, or in this K equation up there. So in order to have a value that's greater than 1, we need a higher amount of products to make that possible. So say we had just 100 products to 2 reactants. We're going to have a value greater than 1. We're going to have 50. So that means that we are going to have more products that are formed when we're at equilibrium. Whereas if we're looking at a K value that is less than 1, again, our products over reactants, in order to have a value less than 1, we need a lot of reactants in that denominator to make this fraction really, really small. So that could be like the opposite. We could have 2 over 100, and that's going to give us a really small value. And so that means we have a lot of reactants when we have met equilibrium. So when I say more products or more reactants, I am generally saying that the products are favored. There are more products when we're at equilibrium. So that is the favored side of a particular reaction. But if our K value is less than 1, then our reactants are favored. We have more reactants in comparison to our products. Okay, now moving on to our reaction quotient, which is represented by Q. Q is going to be represented by the same exact equation. But the thing is that Q isn't represented, or isn't always represented, at equilibrium. So Q is used as a measure to see what values do I have, or how many products do I have in comparison to reactants, and how does that vary versus what I want at equilibrium. So say I had, for some reason, a lot of products, and at equilibrium maybe we have a K value less than 1, so then we need to make more reactants. So this Q is just showing that at the moment, maybe the first few seconds of a reaction, we have a lot of products, but then we're going to shift to form more reactants in order to get to that K value, to that equilibrium. So Q is just a measure of comparison to see when are we going to reach equilibrium, or where are we at right now in this reaction? So whenever you see that Q equals K, that is going to mean we're at equilibrium. So what does it mean if we have a Q value that's greater than K? So I like to think of it as always products of reactants. So if we have a really high Q value, then that means we have a lot of products, making that value so big in comparison to our K value, which is also represented by products of reactants. So if we have so many products, we need to get rid of those products in order to reach our K value. So we're going to form more reactants. So what does Q greater than K mean? It means at the moment, we have a lot of products. So we need to shift the reaction to the reactants. So at the moment, when Q is bigger than K, we have so many products and we need to get rid of some of those and form more reactants. And then lastly, if we have a K value that is, oh, this just means the same thing. Let me flip this. So if we have a Q value that's less than K, we are going to have a lot of reactants. So if this is representing our Q, we have a really small Q value. So that means we have more reactants in comparison to our K value. So if we have a lot of reactants, then we need to get rid of some of those and we need to make some of our products. So what does this mean? We have a lot of reactants. So we need to shift the reaction to the products. In other words, this reaction will proceed towards the products to get at equilibrium. So in summary, our K value is going to be represented at equilibrium. So we could have more products at equilibrium. We could have more reactants at equilibrium. It could be the same. We could have even amount of products and reactants. It all just depends. So if we have a K value greater than 1, we're going to have a lot of products. If we're going to have a K value less than 1, we're going to have a lot of reactants at equilibrium. So if we don't know what equilibrium is, we're going to use our Q value, or if we're trying to figure out which way reaction is proceeding, if it's not at equilibrium, we're going to use our Q value at any given time to find out which way is the reaction proceeding, so that way it gets to equilibrium. So if we have a Q value that's greater than K, it means we have right off the bat, we have a lot of products in comparison to what we would normally have at equilibrium. So we're gonna get rid of some of those products and form more reactants. Whereas if our Q value is less than K, that just means we have a lot of reactants at the moment and we need to get some of those and we need to shift to the products if we want to reach that equilibrium condition that we're looking for. So that is all I have for you, and thank you for watching.